Antonio, what is it?
I put double on.
And you would be right. Now, with our newfound knowledge about doubles, you got to decide, will it go? Here's the neutralizations always go. Now, granted, with a neutralization, you don't always get a precipitate, but neutralizations always go. The real driving force, you made water. Once you get water, it hangs together. It's kind of similar to getting a precipitate in that it comes together, stays together. But doubles, if they are neutralization, see, there's really two subcategories. Actually, in your book, there's three, but we're going to consider two. Double displacement. If you form a precipitate, it will go. If you do a neutralization and you form water, it will go. And then you switch partners. I did this for you today. If I wrote water like this, it would make it a little bit clearer. Now, what happens? Hydrogen is the positive. Phosphate is a polyatomic ion acting as a unit. Positive here. Hydroxide is a polyatomic ion acting as a unit. If you see more than one positive and one negative types, then you've screwed up. Because you're going to have a positive, a negative, which means this must act as a unit. Okay, so the hydrogen goes with the OH. And if we looked up here, a hydrogen, if it takes on a charge, its charge would be what, Kasha? Look at where it is. +1. And our hydroxide is -1. So they go together 1 to 1. And we usually don't write water as HOH, we write it as H2O. And then calcium and the phosphate. How would we write the formula? What's the charge on calcium? Look at its position up there.
2 plus.
2 plus. And then the phosphate, as a unit, is -3. Okay, double cross down. And so the 3 comes here. The 2 goes there. We have our formula. And if you do it the academic way, you say you've got to have neutral charge. And this was the point you were hung up on a minute ago, Nina. But if I have 3 of these, 3 times +2 is +6. -3 times 2 is -6. Neutral compound. But the double cross works great. We can do a double cross down. Also, here's another wonderful trick. What if you already know this formula? But you'd like to know the charge on that phosphate unit. Double cross up, add the signs. And so you can use the double cross down when you're trying to write the formulas, but if you got the formula already and you want to know charges, double cross up. Now, occasionally that will fail you. This little thing right here. If you tried the double cross up there, it would fail you because we know a sulfur is -2. And so that means this copper has to be what? +2. Good. Okay, now, that finished that last part of the chapter where it was the 4 types of reactions. And keep in mind, one more time, if you have combination or decomposition, assume they always go. What I give you, assume it will go, and I will give you the products. If it's single displacement and double displacement, I'm going to work you a lot harder. You've got to make a decision. Will they go? If it's single, you look at the activity series, or you look at the halogens if it's negative. And if it's double, then you look at, do I get a precipitate or do I get water? And it will go. And then you have to predict products. And that takes some practice. let's move on, because I'd like to get this stuff introduced, because I think there's always this digestion time. You hear it today, you think about it some tomorrow, you come back to class on Thursday, you hear it again. And so let's hit some of this new stuff. Yeah, Bruce?
Just real quick, you may have already answered this, but if you have the PO4 by itself, how do you